Hi, this is Travis Krieghauser. I'm a field sales agronomist with DuPont Pioneer in Northeast Kansas. I want to take the opportunity to present to you a simple and easy to use software program that sales professionals and Pioneer employees have at their disposal. And it's a tool that can really help us understand and interpret the impact that the growing environment has on our different product lines. This product is known as the Field Environment Profile. It was made available to us in early 2013. It would have been automatically installed on ref computers at that time when you had a communication. But if you've not already seen this tool on your desktop, let me minimize this. You'll see the icon looks very similar to this. When you double click on that icon, you open it up, you'll go back and you'll see this program exactly like what I have on my screen. You also notice that on my screen, I've already got a few reports that I've ran. It keeps these reports handy after you create them, so you'll end up building a pretty good list here. But I've got a few on hand here that we're going to work through this demonstration today. As we look at the other components that are available within this screen, we've got two tabs up top. We've got the Field Environment Profile, and then we've also got a Help tab. And the Help tab is actually very helpful. There's a user guide. If you double click on that, you'll have a PDF file that will open up, and it lists all the different parameters that you use, as well as kind of gives you some background on what to put in for each one of the fields as you start to create your report. So that's one I would print off and have handy. There's also this location report guide, and when you click on that, it's going to pop open a PowerPoint presentation. I'll bring it over on the screen here. But this PowerPoint presentation has multiple different slides in it, and these slides represent each page of the output report from your request that you submitted. So you'll have your first page, your location report. You'll have a lot of detailed information on some of these graphs we're going to talk about here in a minute, and what each one of these different colors and graphs and bars mean. It's also got a lot of information down here I highly encourage you to read through and understand, because it is the background information on what drives this program, where the data comes from, how it's used, so that you can have a complete understanding of what this data is, how to interpret it, and how to communicate it most importantly with the customer or amongst ourselves as we try to figure out, what different situations or environmental components impacted performance across different products. I'm going to go ahead and close that out there. But when we're back on this page here, again, you can see the different ports that I've ran. If you go back to that Field Environment Profile tab up top on the left, you click on that. You can click on New Report, and at that point, we're ready to begin a new report. After we click on that New Report button, you're going to see a screen that looks just like this. We've got a lot of criteria we need to fill out for this search or for this request. We've got some of these different fields we need to enter in that have a asterisk by them, this kind of orange asterisk. That means those fields are required, so we need to make sure that we have something in there. I'm going to go ahead and just give this a title for a crop. We've got a multitude of crops here. I'm just going to go ahead and select the corn silage, and my planting rate, I'm going to put it at 25,000. And this is a non-irrigated or dry land field, so I'm going to select non-irrigated. You also have that option to select irrigation if you need to. We've got previous crop, that was soybeans, and we've got additional information here that's not required, but I'm going to go ahead and enter it anyway so you can see what it looks like. You can put the account manager name, you can put the operation name, you can put the farm name, and as well as the field name. And then there's another important component up here that we need to get right, which is the planting date. So we're going to want to go back and select the planting date for these particular fields or field. And I'm going to select April 6th, which was an actual first planting date that we had in 2013. And then for harvest date, I could either stop the report here at the current date, which is August 10th, or I can go ahead and just select out to a somewhat practical harvest date. I'm just going to pick October 10th. And that will allow this tool to give us some estimation of where we are using predictive models and how we may finish out in terms of GDUs and some other components we'll get into in a minute. So I like to put that harvest date in there. If this is post-harvest and you actually have the actual harvest date, please use that harvest date, and it'll give you a nice assessment of what happened during the course of that year. And then we need to go in and enter our products. You click on this area for entering a product, it'll bring up this drop down. You can scroll through and find products in a numerical / alphabetical type order, or what I prefer to do is just start typing. It brings them up a lot faster. So if you do P0876, we can select from there. We can do P1151 AM, we'll select that one. Let's do P1498, select the AM. And let's do P2088, get a full season one in there. So now we've got our products listed. You can list up to 8. Any more than probably 6 or upwards of 8, the graph starts to get a little bit small and harder to visually interpret. But I like to do these 4 here, and we can just use the scenario that these 4 are all planted in relatively close proximity to each other, and we want to figure out why some of these products maybe didn't perform as well as some of the other products that we have in the list. And to do that, we want to make sure to get the latitude and longitude. This needs to be pretty close. So what we can do is either punch that in if we've got a Field 360 note and we emailed that note to ourselves, we can take the GPS coordinates right off there and just type them in, or we can use this tool here, this Bing map, and use that to zoom in and place a pin on the location or even the actual field. If this is a little bit small to work with, I kind of like to expand the map, so you can click this right here. We'll expand this into a larger viewable version, and it's going to zoom in on the central United States. And you can either use your mouse cursor, or you can use these icons over here, the plus minus, to be able to zoom in. I'll just use my mouse here a little bit, and I want to zoom in on Belleville. There's Belleville, Kansas. I'm just going to place the pin right on top of the town just to have a reference point. So what I'll do is just double click there. It'll place the pin. If I don't like where that pin was placed, or maybe I was off a little bit, I can double click over here and it's going to place that pin wherever I want it. Once I have it positioned where I want, I'm just going to go ahead and click this use push pin location. That's going to grab the GPS coordinates of where I placed that pin. It's going to automatically fill in some of this location detail information down here in terms of state and county. And at this point, I've got everything filled out that I need for this request. So I'm just going to go up here and click Submit Request. It's going to say that this request has been saved successfully. I'll just click OK. And then it'll go back to this screen where we started, and you can see we've got all these different reports here now. And we're at the point now where we've got this one here is just being requested. So that's our report we just submitted. We're going to need to wait for that to get completed, so it's going to use the crop modeling information. It's also going to start bringing in the weather data history, and we're going to start having that calculation happen. And we need to let that occur, and that can take upwards of an hour. The recommendation initially was that you just plan on doing this and let it run overnight so that any report, regardless of how large it is, will be available to you in the morning. So that's one piece of the puzzle that we need to make sure to consider, is that we're not running this report while we're sitting there with a customer and waiting for the end result to come in. So it's something that needs to be done ahead of time at this point. As you can see, we're at the point now where that report status has changed over from requested to completed. So at this point, we can go ahead and double click. And as this thing opens up, we're going to see that this first page here is kind of a summary page. We've got that information that we input that was not required. We went ahead and put that in there for that request. We've got the account manager information. We've got crop here. We've got our crop. We've got previous crop as soybeans, our planting date. We've got our harvest date. We've got the irrigation set to non-irrigated, that planting rate of 25,000. Then we've got our GPS coordinates down here, and we can see on this map over on the right side, we've got NRCS soil maps available with the GPS coordinate represented by that dot. And then we've got precipitation, solar radiation, and GDUs down here. We've got total accumulated to this point, and then we've got the deviation. And that deviation is this total number and how it differs from the 10-year average. So right now for this particular location where we had up in Belleville, we are 1.3 inches above the 10-year average for precipitation. We're almost 100 units behind in solar radiation, and we're about 178 units behind for growing degrees at this location as well. And then that date range is running through from 3/7 to 10/10. So there's some estimates included in there, which we'll see in just a little bit. On the second page, we'll be able to look at precipitation. I want to start down here with the growth stages. What you're seeing is the different CRM represented on this left side. We've got our products that we selected, the 876, the 1151, 1498, and 2088. And then we've got those kind of set out in a bar graph by growth stage, with the legend being right up here. So we start with pre-plant. So we've got 30 days prior to that planting date that we put in of April 6th. You'll see that allows for us on this precipitation to kind of get a feel of what that soil profile might be like. Again, it's just an estimate, but we see here that we've got germination. We've got that phase going on through here in yellow. We'll get through that juvenile stage of V1 to V7, then we make the transition into our vegetative growth up to tassel time. Of course, reproductive stage, we've got that 7-day window through there, and we've got grain fill followed by dry down. So when you look at those different stages, you can look directly above those and kind of line up and see what's going on with the environment. And obviously you can see here things are going pretty good along through May. We're not looking too shabby. We're sitting at 0 in terms of precipitation here. So every little bump or every little bar here is a precipitation event. And the key thing to remember is that for precipitation, it's not generally going to be the most accurate estimate. Some of the future pages we'll look at will be much greater in accuracy. The precipitation is not as accurate because all these estimates are based on laying a 18-mile by 18-mile square grid across North America, and wherever you fall within there, there's different weather reporting stations, there's NOAA stations, there's approved Pioneer weather stations, and depending on the saturation that you have for weather data, those estimates could be more accurate or less accurate. Based on your GPS coordinate within that grid, it'll use the closest proximity weather station to get those estimates. But again, the key thing to remember is that precipitation isn't going to be as accurate, obviously, within that grid as some of these other components when you look at like temperature and solar radiation and GDUs. So what we're seeing here is a kind of a gross estimate of what happened on rain events. You can see we've got those individual events, and then we've got this continuous blue line that kind of moves through this graph. And that continuous blue line represents the cumulative precipitation deviation from the 10-year average. So as this thing floats to 0, you can see that we're sitting pretty close. We're riding a little bit below the 10-year average right in here, right above the 10-year average right in here, and then we have a drastic dip below that 10-year average. So based on what we would normally see, what we consider normal production situation for corn, we're going through a ton of stress here in terms of moisture. And of course, that was easily represented by what we saw here this summer of 2013. And then as we moved into the later part of July and August, we started getting some pretty significant rain events, and we bumped right above that 10-year average again. So just something to note as you look at reproductive stages, you look in these early vegetative growth stages where you know that we're determining, in this period here, kernel row, kernels around, some of those factors determining what that cob is going to look like, and then also determining later on, what we have in terms of success of filling that cob with reproductive stages. So just something to look at and evaluate. You can see here that obviously during reproductive stages we had some stress. So what other stress did we have? This one here is temperature. So we're looking at the same type of deal, same setup below, and we can easily see that we had some very cold stress. So temperatures below 32 degrees represented by this turquoise color. So we had freeze events, of course, pre-planting, but then even after planting through germination, we definitely had some cold stress. We had some freezing conditions. We had a lot of days where we were in between that 32 and 50 degree temperature zone, which was pretty stressful for us. And we had slow emergence. We followed that into the juvenile stage, and then we got into this point where we're more vegetative growth. We see some pretty ideal type situations in terms of temperature, but then it doesn't take long before we move into seeing some extremes where we have temperatures above 90 degrees. We also held some pretty high humidities at those points. And you can relate that when you see multiple days above that 90-degree temperature zone. That was kind of in the bulk of where our pollination was with some of these earlier maturities. As you look to some of the later maturities, looks like maybe we got out of some of that higher stress area or multiple days of stress. So we probably had some decent days for pollination within there. And hopefully those fuller season products, if you see something in the field where the early season products maybe struggled less and the fuller season ones had a better pollination rate or better success of filling a full year, that might be something you can attribute to back to temperature, as well as that previous graph where we had rainfall. And here again, this is our simulation date. So at this point, everything beyond this is just simulation based on growth models and historic rainfall patterns, temperature patterns, so forth. So more of just an estimate, but we move into that dry down phase, and we'll see what we get the remainder of 2013 in terms of hopefully some warmer weather and sunnier weather, which is exactly what you can see here with this solar radiation report. You can see that 0 is our average, and every bump or every one of these ticks that go above or below the line represents an increase above normal or below normal for solar radiation accumulation. Of course, the sun is the energy and the power that drives our yield. As we look in here, we're doing pretty good on this blue continuous line, again being the 10-year average. we're staying above average for the most part, but then all of a sudden we get into August and we have a drastic dip. We've had a lot of cooler weather and a lot of rain events, as well as a lot of cloudy days, and you can see that we've drastically fallen from that here to the simulated date of today in terms of solar radiation accumulation. Just one more piece of the pie that we can use to help decipher and determine what impact or what components were impacting the hybrids as they were out there in the field. The big thing to kind of look at is to see where that stress falls during those critical growth periods that we all know and understand, and help that to try and communicate and understand what may have occurred as we look at some of those ears out in the field in the middle of the season. In summary, there's a few key points I want to just make sure we walk away with. And that's that this is a very handy tool and a powerful tool, but then again, it's only as accurate as the data that it has available. So as we think about those estimates for temperature, GDU, and solar radiation, as well as the crop growth stage variables, those are going to be very accurate, and those are part of Pioneer's proprietary in-class technologies and our in-depth understanding of our different hybrids. But we're of course going to have some fields that have more weather stations within that 18 mile by 18 mile grid. And so precipitation estimates are generally less accurate and can be somewhat more variable than those other components. We want to make sure that we use local knowledge when you assess the moisture situation and the stress by growth stage. Another component is if you are running this report and you've got an irrigated field, the report accounts for that to some extent. But of course, the moisture stress is going to be something that is best understood by visually seeing the performance of the hybrid in those irrigated fields and knowing what we had in terms of irrigation capacity and timing. The last point that I want to make is in regards to how we use this tool. Again, this demonstration here kind of relates to what we're seeing in 2013 as we're having communications and questions come from the field regarding how and why pollination maybe didn't live up to expectations. We can use this tool to kind of assess some of those situations, see if we can find an answer and how the environment dictated our overall success. And again, when we look towards the end of the year, we're going to be able to have a lot more data as we wrap up the growing season, use that finalized harvest date to put into these reports. We're going to have more data that is accumulated post-season to be able to get better estimates of these independent variables. But it'll be a good situation where if you have a customer and he's got maybe a couple different Pioneer products in the split planter type situation, planted in the same field or multiple fields within close proximity to each other, you've got drastic differences in performance by product, and there's a little bit of a surprise there. You can use this tool to go in and hopefully determine if maturity or growth stage for different products, if that was the variable that really dictated the performance in the field based on environmental factor overwhelming one hybrid versus another. And with that, I just want to say thank you and wish you good luck, as well as remind you to go back to that initial tab for help and print off some of that documentation and use that documentation, read through it, and make sure that it fills any gaps or questions you might have after watching this video.